So let's look at this part of the concept here, which is how we actually determine the shape of the curve by using a second derivative test. Actually, this is one of the tests which we use quite often. So we have already explored how to actually to determine whether the max, mean, or stationary point of inflection using the first derivative test. Now we're looking at the second derivative test, okay? Now, what is the significance for the second derivative test is actually, see this as d square y dx square, which is actually d dx dy dx, okay? Now, this dy dx here is the gradient. In other words, it's the change of y with respect to x. As x changes, how much y is actually changing. So if you put d dx here as a gradient, okay, this in layman term, it just means how the gradient changes, okay? How the gradient changes with respect to x. Okay, so that's the main point. That is how the gradient changes with respect to x. So now, how do we actually understand it? How come for maximum point you're looking at dy dx less than 0, and how come for minimum point is f prime x is bigger less than 0, which is negative, and this is positive, and when this is equals to 0, why? Okay, so let's try to understand that. So now the first thing is actually second derivative test. You don't really need to understand the concept behind it, but I'm just going to explain to you so that you appreciate it. Okay, what you need to do is just generate and see whether the second derivative value is negative, positive, or 0. If it's negative, then at that juncture, at that point there, is a maximum point. If it's a positive value, then it's a minimum point, and it's 0 is inflection. So usually what I tell students is it works a bit different. So if when it's negative, it's max, right? So when it's negative, you will think that but negative means it's maximum point. Positive means is minimum point. 0 is just point of inflection. Okay, so with enough practice, you will know that. Now I'm going to show you why is it so that you appreciate it. So let's just look at this maximum point here. So I like usual, I want you to look at the gradient here. So I start out at this point here, as you could see. When I start with this point, you realize that my gradient actually is increasing, right? So is it increasing? Oh, it's actually decreasing, sorry. So from 11.52, if I move towards the right, okay, so as you could see, as I move my A from minus 3.2 meaning the x-axis here, if I increase it, my gradient is actually decreasing. You see, even when it passes through, so from 7, I go down to 0, and from 0, I drop down to negative. Do you see that? So around this juncture here, the gradient is actually decreasing with respect to x. That's why second derivative test is very powerful, because you just need to check if it's negative, then it's a maximum point. What about the minimum point? Now, the minimum point here, as you increase, okay, there's a point of inflection here, actually a very slight one, but never mind. We look at this point. Okay, so let's start with this point here, which is minus 3. As we increase, it goes to 0, and it will increase again. Okay, so from minus 2, so minus 7, negative 2, I increase to 0, right? Minus 2 to 0 is increasing all the way up. So in other words, the gradient is actually increasing with respect to x. I'm looking at the value, just the value. Okay, then after which we look at the point of inflection. Point of inflection will be like that. So for this case here, as you could see, it's always is just how do we call it? This is going to 0 and going back up again. So there's no change in sign. It's decreasing, but there's no change instantaneously at that juncture. There's no change in the sign. Okay, so that is why the gradient doesn't change sign. So that's why there's a point of inflection. So that's how we know this, understand this concept here. So I'll just apply the questions in the subsequent questions, and I'll see you there, and let me know if you have any questions. Okay, yeah, keep practicing. Bye.